So vanakkam. So we will continue our lecture on engineering seismology. So we have been discussing about the zonation. Okay. So what is meant by zonation? So why zonations are important? Why we need zonation? So we have seen that zonation can be done at continental level and country level, regional level and site level. So we have also seen that where you can adopt site level. Okay, site level can be adapted for the important structures and important facilities. Okay, so where like a dam, a nuclear power plant. Okay, so the multi-story apartments where the 1,000 families are kept together. So those are all the places site level studies may be required. Okay, so the zonation defines, okay, basically, so the area which has a similar seismic activity. Okay, that is the same. So we will continue our zonation concept. We also seen three type of zonation as macro level, micro level and nano level. Okay, but this concept has been developed in 1999. So where there is a considerable lack of scientific advancement. Okay, so about it is closely about 20 years back. Now we are advanced well. So where people also looking for the very minute level of information for the design and other things. We also try to understand what is the difference between the seismic zone and the seismic risk. We should not misunderstood risk as a zone, zone as a risk. We also seen that zonation map for the general requirement, zonation map for engineering requirement, zonation map. Okay, so its component we have discussed, and also we have seen seismicity map. Okay, the seismic zone map and the seismicity maps are completely different. So if you recall what we defined as a seismic zonation, so the seismic zonation, okay, seismic microzonation is a generic name, subdivide a region into different zones with each zone having the same potential for the earthquake effect. So subdividing the region into different zone with each zone having the same potential for the earthquake hazard. That means if you mark some area as a zone X, okay, the X will have the similar seismic effect. That was the message which you have to see. That means if there is a difference in the earthquake effect, it has to be divided as a different zone. Okay. So defining their specific seismic behavior, the engineering design and land use planning can be taken up. Okay, by knowing the seismic behavior, engineering design and land use. So seismic microzonation has been subdivided into three major components. One is that evaluation of the expected input ground motion at bedrock level, local site effect and ground response analysis, how the wave changes due to the local material at that particular place, and then prepare the map which shows this as well as this in the mapping form. Okay, like this. So like this it is showing the mapping form. This is the process of seismic zonation. As we have seen that the older procedures and methodology looks very complicated, and the scale what they give also very vague. So India has a seismic zonation map which we will be discussing in the later classes in detail. Okay, how the current Indian seismic zonation map is there. So part of during my research as well as the studies, I found that the seismic zonation concept, okay, practiced in India is not appropriate. Okay, so I come up with the new methodology for the seismic zonation. So this methodology only now being adopted in the country for preparation of microzonation of several urban cities, okay, in the India. Okay, this methodology what I developed. This methodology I developed considering all the aspects which affect the earthquake, because if you see the country level or macro zonation, they say that only consider seismicity and geology. So what about the geotechnical, what about the liquefaction? So all those things are not included there. So in order to overcome all those things, I prepared a methodology which is irrespective of the region one can adopt. Okay, depends upon the region what are the steps they can follow and what are the parameters they can estimate. Finally, you will get a map which shows a hazard index value or hazard value as a representation at a particular place. That if is done throughout the country similarly for all the region, merging up all of them, you will get a proper seismic zonation map of India. Okay. So, right now the zonation map of India does not consider the systematic analysis of the existing data and state of art knowledge available in the engineering seismology. That is the reason this has been practiced. Okay. So, if we see that the seismic microzonation is actually can be defined as a subdivision of the region as relative similar exposure to various earthquake related activities or identification of individual area having different potential of the earthquake hazard. So, the seismic zonation map basically should show some earthquake comes, how that earthquake will affect that area, okay, how that earthquake will respond to the area. So, wherever the similar response and the effect are there, that area can be gapped as a single zonation number. So, that means you will have the different zonation value at same city. So, the important places concern for which the seismic microzonation need to be carried out is a urban or upcoming urban area that falls under the high seismic hazard zone, and for the places where the moderate or low hazard, but where amplification would be expected to because of the local geology. So, the seismic zonation has to be taken up for the places where many people are living, the important places of concern. Okay. So, that is why India is they are doing for the most of the urban settlement where the population exceeding 5 lakh. Okay. So, you can see how many cities we have with 5 lakh, because those cities actually in a seismic zonation present Indian seismic code clubbed as a single zone. They did not consider a soil variation in that, liquefaction process in that, which is also important. Then hilly area again landslide phenomena and tsunami in the coastal region. So, these parameters not gone into the present code zonation map. That is why the zonation map has to include all of them. Okay. So, where this is with respect to bedrock level as well as surface level. So, depends upon the complex geological formation, the seismicity experienced in that area, and then those things to be clubbed together to get your zonation identification of the area where you can do the zonation map. So, right now India decided that based on the population, this almost like I think 38 cities has been selected for seismic microzonation work. So, you can Google it, the MOS, Ministry of Earth Science microzonation work. Okay. So, in that 38 city already 3 city work was awarded, 4 city work was awarded, 3 city work was actually awarded to the company who is academically interacting with me, okay, but like SECON. They are doing the microzonation of Mangalore, Coimbatore and Bhubaneswar. So, I am the academic partner where I am helping them to get a microzonation work done, experimental work required for that done properly. The other city is Chennai, which is awarded to the FIGRO. So, they are doing other team. So, recently there is a 8 more city has been awarded, that is awarded to the ISR. Okay. So, International Seismology ISR, okay, International Seismology Research Center, okay, ISR Gandhinagar is there. So, they got actually 8 city where they will be doing for the other 8 places for the microzonation work. So, this microzonation work requires a detailed understanding of all the aspect which is required or cause a harm to human being. So, the contrasting seismic response observed even with a short distance, a small changes in the geology of the site. Moreover, designing construction structures were to withstand consecutive future earthquake economically not viable. So, this seismic response, if the negligible or it is not very high, we no need to worry too much about the microzonation concept itself. So, microzonation map can serve many purpose, okay, for the urban development authorities. Okay. So, seismic design of building structure. So, what are those for the assessment of seismic risk of existing structure and construction management of the land use for other future construction, and then defense installation, heavy industry, important structures like dams, nuclear power, other power. So, the seismic zonation map can be used to design a new building. The values obtained for seismic zonation studies can be used to design a new building and retrofit a existing building, so that you will avoid damage due to any future earthquake. Apart from that, assess how much risk we are expecting from this, how many building going to collapse, how many building going to partially collapse, how many, if this building collapse, how many people will die, how many economical losses, okay, how many fatalities. So those kind of modeling, seismic vulnerability and risk assessment also need a zonation input. Okay. So then the land use planning and management, so locating important facilities, okay, so the important buildings. So all those things we need a seismic zonation map. And then the construction of defense installation, heavy industries, important structures, okay, all those planning, all the, then the dam, nuclear power and other public utility service, where to be placed, okay, how that area is safe. So all those, okay, can be decided based on the your seismic zonation map, which is systematically prepared. So as I told you that seismic microzonation of India, okay, is not done, and zonation map during 2007, okay, 2004 when I started my PhD. So the zonation map of the country also not up to state of art knowledge. So anyway we will be discussing about the Indian seismic code in the next class. So that time we will understand how our Indian seismic code, so what is the state of art knowledge gone into that, so that it will be easy to relate what I am talking now. So by considering all this is, by understanding seismic hazard different level where it affects a people, a systematic procedure has been developed that is called as a methodology for microzonation or steps for seismic microzonation of any area. So this is the universal steps, anywhere can be adopted, and any scale, okay, this is nothing to do with the scale, because the previous method what is suggested, it is actually confined to the level, okay, scale or grade. So here I say that you do scale depends upon your funding availability, but you try to consider all of them systematically. For example, if you have the better funding, you can go for the lower scale 1:5,000, 1:10,000. If you do not have this funding, you can go for 1:25,000, 1:50,000, depends on that. So the microzonation process has been divided as a 6 major steps, and then finally integrating one step 7. So the first and foremost step is basically to get earthquake hazard analysis at a particular location. So in our course we will be discussing only the earthquake hazard estimation only. So beyond that actually you need a civil engineering background knowledge, which we are not going to discuss. Maybe in the future I may offer a course on NPTEL itself on other part, that is anyway future, but right now we will learn. So I will discuss the detailed steps, because why it has to be taken care and how it is be taken care. So the seismic hazard analysis and estimating the hazard at bedrock means, so basically as we discussed that the earthquakes are happening in that. So this is your site, okay, so then the waves are, this is the source. So now we understand that what is the source and how the waves are moving. As we have seen that there is a continuous soil layers. So this reaches here, and then so this is basically we call it as a engineering bedrock, which we have discussed. This is the seismic bedrock, okay, this also we discussed. So the hazard estimation, okay, the first step taking care of up to this part. This is the first part of seismic hazard analysis, okay. So how it will take care, basically we have to characterize this, measure this property well, and know this property well, and then estimate what is the hazard at this level reliably, okay. So this can be done, okay, by looking at and studying a geology data of the region, okay. So the input will be your geology data. Second, seismology data. Seismology data means your earthquake record, earthquake history, so okay, all those things. So then even the intensity maps. So those are all the seismology data. The another one is the seismotectonic data. So seismotectonic data means the data which is obtained or which gives a source location, source parameters, dip, strike angle, which we have discussed, okay, the fault length, okay, the fault orientation. So all those things are seismic. Then the deep geophysical data, where which gives here your VP and VS, VP value at particular place. So we have seen that these values are useful to model, okay, to simulate synthetically ground motion data. So those are all the. Apart from that, you should also look at a aerial data, okay, like remote sensing data to see how the area is geologically, geomorphologically different. Okay. Then the ground motion prediction equation or attenuation relation. So, these are all the input which is required, which you can obtain by going through a literature and also carrying out some of the experimental studies. For example, the source activity can be identified by taking up a active fault study, which we have seen, deep geophysical studies and all those things. So, once you get all this information, so you can do seismic hazard analysis by deterministic or probabilistic way. So, the deterministic way, probabilistic way we will discuss in detail in part of our class, which we are going to teach you part of this course. So, once you are done that, then finally you will expect some of the output from this method. One is that what is the maximum possible earthquake in the region, like maximum credible earthquake. Second is, so what are the active sources or vulnerable sources. You can see what are the active sources and vulnerable sources. Then if this earthquake comes, how your acceleration time history will look like. So, this is a synthetic ground motion. As we told that some of the analysis you need a time series analysis, you need a synthetic data. So, that okay. Then the hazard parameters in terms of PGV, PGD, PGA and then the duration and the intensity, those are all the hazard parameters. So, these values are basically recorded, okay, or estimated at a bedrock level. Okay. So, we particularly the rock level peak ground acceleration, which is one of the important input for the engineering requirement. We have seen that the zonation map has to give you the PGA distribution, peak ground acceleration distributed in the region. So, that map preparation should be then the hazard curve. So, when you do your probabilistic hazard analysis, okay, you have to produce what is the recurrence rate and a given time and a period, reliability and then probability, okay, that kind of hazard curve. So, this entire part is unique irrespective of the region, all the region this has to be done. Okay. So, the once you are done that, you have to make the hazard to propagate surface. So, in that case, okay, so making this part, so making this part basically, so you have to basically see how the waves are propagating. If you want to see how the wave get modified on due to the local site effect, first you have to understand what material is here, what properties, dynamic properties, static property. As we have seen that the wave propagation controlled by the constraint and shear modulus density Poisson ratio, that has to be estimated. That process is called as a site characterization. So, in that again you look at geology, geomorphology and soil map by drilling a borehole and soil strength estimation in the form of VS value, SPTN value. Okay. Then shallow geophysical survey. So, shallow means you will concentrate up to the bedrock level, not go very deep. Those kind of study has to be taken and those data is a input, and then you do systematically characterize that place based on the this property estimation, like rock depth mapping you prepare, subsurface model you develop, how the bore log thickness, soil thickness varies, 3D bore log models and SPTN corrections which is required for the liquefaction assessment, VS mapping, VS 30 mapping and N versus VS relation, so that some places where it is not possible to measure VS, you can use existing bore log data. So, for this purpose even you can collect bore log from different places and you can use it as long as the bore logs are reliable. So, this site characterization itself a class which cover 3-4 hours, but this is not part of our scope. Okay. So, only up to hazard analysis will stop these courses. So, later stage if you are interested, I teach this course for our MTech and PhD students, or in case if I offer that course for you, then you can understand how the site characterization is done. Right now we are going to demonstrate that. So, once you are done that, okay, this is you are characterizing the properties in the materials here. Then how the waves going to modify because of this material, that analysis called as a site response analysis. Okay, the site response analysis can be done theoretically by experimentally. So, the input arrived from these two method. Okay. So, this one and this one go as a input here, because you need a bedrock earthquake level, hazard level, and then the soil property, then you estimate what is the modification happens, how you quantify, that is the output you get. So, basically how the waves are amplified. So, the amplification map will be generated, then how the peak ground accelerations are modified at the ground surface, okay, how the period of soil column changes, okay, the fundamental natural frequency of the soil column, spectral acceleration for the different frequencies, response spectrum, design spectrum. Okay. So, then the comparative study of different approaches and how the reliable result you can obtain. So, that is obtained in the step 3 of the zonation process, microzonation. Once you are done that, so now you know that we have estimated the ground motion amplified at the ground surface. Okay. So, but as I told you that this amplified ground motion, if the soils are cohesionless and particle, it causes a liquefaction or soil failure. That has to be assessed. Why? Because even if you consider the design force for this your structure, if the soil is liquefied, the structure will go inside. Okay, it suck inside or it fall. Okay, so structure may be intact, but the building may fall. So, that kind of problem comes, that has to be accounted. That is why the liquefaction analysis should be part of the microzonation. So, for the again here you study the details what you obtained from the last 3 steps will be clubbed together. So, that is why you can see basically I have been marking a arrow continuously, you can see. So, each one is linked and you can also see the output from each one is coming as a input to other. So, the liquefaction, what is the surface amplified acceleration which is obtained here, the magnitude of earthquake which is obtained the controlled magnitude, soil property which is obtained steps 2, and then you do a detailed liquefaction analysis and try to prepare a liquefaction susceptibility map and factor of safety table and factor of safety map and liquefaction potential index and susceptibility map. Finally, you will say that delineation of liquefiable, non-liquefiable area, liquefiable area how much ground deformation it causes. So, those are all the output will be produced from this step. So, this is the very important step, particularly when the regions have the cohesionless soil, non-clay soil, those kind of places liquefactions are important. So, you can see that first 3 step is important for almost all the region. This is only applicable to the region where the cohesionless soil is. If there is a clay soil, you no need to worry about the liquefaction. Okay, but you have to check it is the liquefaction is possible or not. So, once you are done that, so as you know that in the land area, even though your site base you have the liquefied soil houses are there, but you are foot of the hill, then the hill slide will collapse a house, will damage a house. So, that means you have to assess a landslide in this region to prevent the land collapse or mass soil movement in your region. So, that landslide requires here the land slide assessment parameters such as geology, hydrology data, topography and geotechnical data and pre-existing stability history. So, this will be used to assess a potential landslide possibility and prepare a landslide zonation map with respect to static condition. Static condition means no earthquake, dynamic condition with earthquake. Okay. So, how much mass of land will move, how much it will displace, what is the force you expect to your house. Okay. Those are all the parameters should be assessed here. This is only applicable to the only region with where hill is there, not all the place. So, you may be settled in the valley, okay, but you should consider that your upstream side or other nearby area you have the hill which will affect you, you have to check or not. So, once that is done, okay, the coastal area as we have seen that the tsunami is one of the major concern where 2004 lot of people died due to tsunami. So, you need to consider the tsunami assessment. For the tsunami assessment, your seismic study area, okay, or the study area what you consider, you should go beyond the damage level. For example, as I said that Indian earthquake, North India the damage is caused up to 750 km, South India up to 500 km based on the isosysmal map which is available. So, the tsunami you have to go for the 2500 kilometers. Why? Because as we have seen that the Sumatra earthquake which is roughly 1500 kilometer and above caused tsunami. So in that case, any tsunamogenic sources located more than 2500 kilometer or up to 2500 kilometer need to be accounted for the tsunami assessment. For that region, you have to prepare a fresh map of information which is called as a tsunamogenic source map for the longer distance. Okay. Then tsunamogenic earthquake estimate. What is the earthquake which causes a tsunami? Tsunami source and the parameter, this the information should collect and do the tsunami hazard assessment and prepare a tsunami modeling, runoff estimation, inundation map, tsunami hazard map. So this is will be your output from this. So now at any given region, depends upon the where it is located, you could be able to assess all the parameters systematically. I didn't discuss each parameter in detail, that is like a separate subject, each one will be taught more than 3-4 hours. Okay, so that is generally I do it for the MTech and PhD students in IISc. So those who are interested to know about this, maybe in the future I can offer this course also sometime. Okay. After doing everything, what you should do, you take all the output as a input here, okay, like seismology, geology, site response, site correction, liquefaction, landslide, and then depends upon the city you can assign a weightage. Okay. So then for example, if you are doing a microzonation of Bangalore, okay, there is no tsunami, there is no hazard, so you can make 0, 0. Liquefaction may be possible, rest of them. So you can assign a weightage and integrate all this hazard using analytical hierarchy procedure, finally develop a zonation map. That zonation map is a complete zonation map. This map consists of all the input, whatever output, whatever discussed in each step. So where the engineer can get a PGA distribution map for design, designer will get hazard index value for getting this one. So this map basically give you a data which will be useful for future risk assessment, vulnerability assessment, exposure knowledge, city planning and development. Such kind of maps are called as a microzonation maps. Okay, this can be done irrespective of the scale, but all the parameter has to be assessed at some level. You cannot skip some of them, only you should skip if it is not valid. For example, if you are doing the microzonation of some city in the Himalayan region, okay, where hills are there, so tsunami may not come there, you can ignore it. Okay. So but landslide should be part of that. If you are doing microzonation of some city in South India where there is no hills are there, then you should remove the landslide part, and if it is not coastal area, you can remove the tsunami part, but rest of the step has to come. So you can see that the first, okay, so the 3-4 steps are essential component of each microzonation. The 5th and 6th one are the region specific. So only the hilly region, this will come. Okay, the coastal region, this will come. Okay, so the tsunami will come on the coastal region. So but integrating all of the whichever is applicable, integrate and finally produce a zonation map which shows a different zone. Okay, 1, 3, 4. So depends upon this analysis. So in our class, we are going to discuss how to do a seismic hazard analysis, which is the first part of the zonation or bedrock level zonation map, because other part we need a geotechnical engineering knowledge, which is generally I am not given as a basic requirement for this course, and also if necessary I will be taking as that as a second level, the like next level engineering seismology course 2 or something like that. So that time we will see. So now we understand how the zonation map up should be prepared. Okay, what is the methodology available. Next class we are going to see what is our current zonation map. Does our current zonation map consider all of them or not? That discussion we are. So far whatever we discussed actually generalized procedure which is applicable throughout the world. So hereafter what we are going to discuss, which will be very specific to India, because we will be talking in terms of application side. As I told you that we are going to talk about the application side. So we will be discussing about the Indian seismic zone map in the next class, followed by the Indian seismicity, and then how to estimate seismic hazard by considering the different advanced methodology, and how you can do the systematic hazard analysis, so that you can prepare a PGA distribution map at bedrock level using seismic hazard analysis. That is not a zonation map, but at least that is the basic component of the zonation map. Okay, that will be discussing in the next class. So with this I close this lecture. So thank you very much for watching this lecture. We will meet on the next class. Thank you very much.